Amperage measures the amount of electricity flowing through a circuit. Voltage measures the electrical pressure that pushes electrons through the circuit. Wattage measures the power consumption of electrical devices and is calculated as volts times amps. When there are conflicting reports about your home's electrical service, it's important to determine the true amperage. One source claims 100 amps, while another claims 60 amps. There are a few possible explanations for this discrepancy. Firstly, your home may have 100 amps entering the electrical panel, but the fuse box may only be rated for 60 amps. This means that the fuse box can only protect the circuits up to a maximum of 60 amps, even though more amperage is available. Secondly, it's possible that one or both electricians misread the amperage rating of the fuse box. Thirdly, older homes may have original wiring that is not capable of handling higher amperage. Two-prong outlets do not provide a ground path for excess electricity, which can create a safety hazard. A 60 amp service may not be sufficient to power modern appliances and electronics, especially if multiple devices are used simultaneously. This can lead to trip breakers, power outages, and potential fire hazards. It is recommended to hire a qualified and licensed electrician to perform a thorough electrical inspection of your home. Request a written report from the electrician stating the amperage of your service and any necessary upgrades. If your service is indeed 60 amps, it's highly recommended to upgrade to a higher amperage service such as 100 amps or 200 amps to ensure safety and meet modern electrical demands. Install surge protectors on all valuable electronic devices to protect them from power surges and fluctuations. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installation. Electrical Safety Foundation International, or ESFI, provides resources for electrical safety. You can also explore electrical inspection on Wikipedia. When determining the amperage of an electrical service, there are several key components and factors to consider. These include the service entrance cable, the main disconnect, the electrical panel, branch circuits, and grounding. The service entrance cable is the cable that brings power from the utility company to the home. Its amperage rating determines the maximum amount of current that can be safely delivered to the electrical panel. The main disconnect is a switch or circuit breaker that allows you to shut off all power to the electrical panel. Its amperage rating should match the amperage rating of the service entrance cable. The electrical panel distributes power to the various circuits in the home. The main breaker in the panel will be rated to protect the service. The individual breakers protecting the branch circuits are rated for the wire gauge used. Branch circuits are the individual circuits that supply power to lights, outlets, and appliances. Each branch circuit has its own circuit breaker or fuse to protect it from overloads. Grounding is a critical safety feature that provides a path for electricity to flow safely back to the source in the event of a fault. It is important to ensure that the electrical system is properly grounded. To accurately determine the amperage of an electrical service, the following steps should be taken. Firstly, locate the service entrance cable and identify its amperage rating. This is usually printed on the cable itself. Secondly, locate the main disconnect and verify that its amperage rating matches the amperage rating of the service entrance cable. Thirdly, inspect the electrical panel to determine the amperage rating of the main breaker. This rating should also match the amperage rating of the service entrance cable and the main disconnect. Fourthly, check the size of the wiring used for the branch circuits. The wiring must be sized appropriately for the amperage of the circuit. For example, 14-gauge copper wire is typically used for 15-amp circuits, while 12-gauge copper wire is used for 20-amp circuits. Fifthly, ensure that the electrical system is properly grounded. This can be verified by checking the grounding electrode conductor and the grounding connections. It is important to note that the amperage of an electrical service should be determined by a qualified electrician. An electrician has the knowledge and experience to safely and accurately assess the electrical system. They can also identify any potential safety hazards and recommend necessary repairs or upgrades. Common electrical problems that may be encountered include overloaded circuits, loose wiring connections, and outdated wiring. Overloaded circuits occur when too many devices are plugged into a single circuit, causing the circuit breaker to trip. Loose wiring connections can cause arcing, which can lead to fires. Outdated wiring may not be able to handle the demands of modern appliances and electronics. When dealing with electrical issues, it is important to take the following safety precautions. Firstly, always turn off the power to the circuit before working on it. This can be done by flipping the circuit breaker or removing the fuse. Secondly, use insulated tools to prevent electrical shock. Thirdly, never work on electrical systems when you are wet or standing in water. Fourthly, if you are not comfortable working on electrical systems, hire a qualified electrician. Here are some tips for improving electrical safety in your home. Firstly, install ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms and kitchens. GFCIs can help prevent electrical shock. Secondly, use surge protectors to protect your electronic devices from power surges. Thirdly, inspect your electrical cords regularly for damage. Replace any damaged cords immediately. Fourthly, do not overload your circuits. If you are constantly tripping circuit breakers, consider adding more circuits. Fifthly, have your electrical system inspected by a qualified electrician every few years. Understanding the basics of electricity, including amperage, voltage, and wattage, is essential for ensuring electrical safety in your home. By taking the necessary precautions and seeking professional help when needed, you can protect yourself and your family from electrical hazards. In addition to the factors already mentioned, several other aspects can influence the determination and upgrade of an electrical service. These include local electrical codes, future electrical needs, energy efficiency, and the age of the existing electrical system. Local electrical codes are regulations that govern the installation and maintenance of electrical systems in a specific area. These codes are typically based on the National Electrical Code, or NEC, but may have additional requirements or modifications. It is important to be familiar with the local electrical codes in your area before making any changes to your electrical system. Future electrical needs should also be considered when determining the amperage of an electrical service. If you plan to add any major appliances or equipment in the future, such as a hot tub or an electric vehicle charger, you will need to ensure that your electrical service is adequate to handle the additional load. Energy efficiency is another important consideration. Upgrading to a higher amperage service can allow you to use more energy-efficient appliances and equipment, which can save you money on your energy bills. The age of the existing electrical system can also affect the decision to upgrade. Older electrical systems may have outdated wiring, panels, and other components that are not capable of handling the demands of modern appliances and electronics. In such cases, it may be necessary to replace the entire electrical system. When upgrading an electrical service, there are several options to consider. These include increasing the amperage of the existing service, adding a subpanel, and replacing the entire electrical system. Increasing the amperage of the existing service involves replacing the service entrance cable, the main disconnect, and the electrical panel with components that are rated for a higher amperage. This is the most common type of electrical service upgrade. Adding a subpanel involves installing a separate electrical panel to provide additional circuits for specific areas or appliances. This can be a good option if you only need to add a few circuits. Replacing the entire electrical system involves replacing all of the wiring, panels, and other components in the home. This is the most expensive option, but it may be necessary if the existing electrical system is outdated or damaged. The cost of upgrading an electrical service can vary depending on several factors, including the type of upgrade, the size of the home, and the location. It is important to get multiple estimates from qualified electricians before making a decision. Here are some additional resources that you may find helpful. The National Electrical Code, or NEC, is a comprehensive set of standards for safe electrical installation. The Electrical Safety Foundation International, or SV, provides resources and information on electrical safety. Your local building department can provide information on local electrical codes and permit requirements. Upgrading your electrical service is a significant investment that can improve the safety and functionality of your home. By considering the factors mentioned above and working with a qualified electrician, you can ensure that your electrical system is adequate to meet your needs for years to come. Always consult with a licensed electrician for any electrical work to ensure safety and compliance with local codes. Improper electrical work can be dangerous and may violate regulations. When assessing the existing electrical system, it's crucial to identify the age and condition of the wiring. Older homes may have wiring that is outdated and no longer meets current safety standards. Common types of outdated wiring include knob and tube wiring and aluminum wiring. Knob and tube wiring is an early type of electrical wiring that was commonly used in homes built before 1940. It consists of single insulated wires supported by porcelain knobs and tubes. Knob and tube wiring is not grounded and can be a fire hazard if it is damaged or improperly installed. Aluminum wiring was used in some homes built in the 1960s and 1970s as a less expensive alternative to copper wiring. However, aluminum wiring is more prone to corrosion and can loosen at connections, creating a fire hazard. If your home has knob and tube wiring or aluminum wiring, it is recommended to have it replaced with modern copper wiring. Another important aspect of electrical safety is proper grounding. Grounding provides a path for electricity to flow safely back to the source in the event of a fault, preventing electrical shock and reducing the risk of fire. A properly grounded electrical system should have a grounding electrode conductor connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode conductor should be sized appropriately for the amperage of the electrical service. In addition to grounding, ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to protect against electrical shock by detecting ground faults and quickly shutting off power to the circuit. GFCIs are required in areas where water is present, such as bathrooms, kitchens, and outdoor outlets. Surge protectors are also essential for protecting electronic devices from power surges. Power surges can damage or destroy electronic devices, so it is important to use surge protectors on all valuable electronics. When choosing surge protectors, look for models with a high joule rating and a low clamping voltage. Electrical panels should be inspected regularly for signs of damage or corrosion. If you notice any problems with your electrical panel, such as trip breakers, flickering lights, or burning smells, have it inspected by a qualified electrician. It is also important to label all of the circuit breakers in your electrical panel so that you can easily identify which breaker controls which circuit. This can be helpful in the event of an electrical problem or when you need to turn off power to a specific circuit. Extension cords should be used sparingly and should never be used as a permanent wiring solution. If you need to run power to an area that does not have an outlet, have an electrician install a new outlet. When using extension cords, be sure to use cords that are rated for the amperage of the appliances or devices that you are plugging into them. Avoid overloading extension cords, as this can create a fire hazard. Light bulbs should be the correct wattage for the fixtures in which they are used. Using light bulbs that are too high wattage can overheat the fixtures and create a fire hazard. Be sure to follow the manufacturer's recommendations for the maximum wattage of light bulbs that can be used in each fixture. Smoke detectors and carbon monoxide detectors are essential safety devices that should be installed in every home. Smoke detectors should be installed on every level of the home and outside of sleeping areas. Carbon monoxide detectors should be installed near sleeping areas and in areas where fuel-burning appliances are used. Test your smoke detectors and carbon monoxide detectors regularly to ensure that they are working properly. Replace the batteries in your smoke detectors and carbon monoxide detectors at least once a year. By following these electrical safety tips, you can help to protect yourself and your family from electrical hazards. Remember, if you are not comfortable working on electrical systems, hire a qualified electrician to do the work for you. Electrical work can be dangerous and should only be performed by someone who is properly trained and experienced. The National Fire Protection Association, or NFPA, is a leading source of information on electrical safety. The NFPA publishes the National Electrical Code, or NEC, which is a widely adopted standard for safe electrical installation. The Electrical Safety Foundation International, or SV, also provides resources and information on electrical safety. You can find more information on electrical safety on the SV website. In addition to the above-mentioned points, it's essential to elaborate on the importance of permits and inspections when undertaking electrical work. Obtaining the necessary permits before starting any electrical project is not just a formality, it's a crucial step to ensure safety and compliance with local regulations. Permits are required for most electrical work, including upgrades, repairs, and new installations. The permit process typically involves submitting plans and specifications to the local building department for review. Once the plans are approved, a permit is issued, allowing the work to proceed. The purpose of permits is to ensure that the electrical work is performed in accordance with the National Electrical Code, or NEC, and other applicable codes and standards. This helps to protect homeowners, occupants, and the community from electrical hazards. Inspections are conducted by qualified electrical inspectors to verify that the electrical work has been performed in accordance with the approved plans and specifications and that it meets all applicable codes and standards. Inspections are typically required at various stages of the electrical work, such as after the wiring is installed but before it is covered up, and after the electrical panel is installed and connected. The inspector will check the wiring, connections, grounding, and other aspects of the electrical system to ensure that they are safe and code compliant. If any violations are found, the inspector will issue a notice of correction requiring the contractor to correct the deficiencies. Once the corrections have been made, the inspector will re-inspect the work to verify that it is now code compliant. Obtaining permits and inspections for electrical work offers several benefits. Firstly, it ensures that the electrical work is performed safely and in accordance with applicable codes and standards. Secondly, it helps to protect homeowners from liability in the event of an electrical fire or other incident. Thirdly, it can increase the value of the home. Fourthly, it provides peace of mind knowing that the electrical system has been inspected and approved by a qualified electrical inspector. When hiring an electrician, it is important to choose a licensed and insured contractor. A licensed electrician has met the requirements for education, experience, and testing established by the state or local licensing board. Insurance protects homeowners from liability in the event of an accident or injury on the job site. Before hiring an electrician, ask to see their license and insurance certificates. Also, check references and read online reviews to get an idea of the electrician's reputation and quality of work. Get a written estimate from the electrician before starting any work. The estimate should include a detailed description of the work to be performed, the materials to be used, and the total cost. Be sure to ask the electrician about any potential additional costs that may arise during the project. Do not pay the entire amount upfront. A reputable electrician will typically require a deposit to cover the cost of materials, with the balance due upon completion of the work. Keep a copy of all contracts, permits, and inspection reports for your records. These documents may be needed in the future for insurance purposes or when selling the home. By following these tips, you can ensure that your electrical work is performed safely, legally, and to satisfaction. Remember, electrical work can be dangerous, so it is always best to hire a qualified and experienced electrician.